Ionic bonding in magnesium oxide MgO. We will explore the formation of ionic bonds in MgO. Magnesium oxide is made up of one magnesium atom and one oxygen atom. There they are, magnesium Mg. Magnesium has 12 electrons, and therefore the electron configuration is 2, 8, 2. So 2 electrons in the first shell, 8 electrons in the second shell, and 2 electrons in the outermost shell. As for oxygen, it has 8 electrons and its electron configuration is 2, 6. So 2 electrons in the first shell and 6 electrons in the outermost shell. Which of the two atoms has a larger tendency to lose electrons? Well, magnesium has 2 valence electrons and oxygen has 6 valence electrons. Oxygen can't lose 6 electrons for magnesium to satisfy the octet rule because it's easier for magnesium to lose its 2 valence electrons for oxygen, so that oxygen would have 8 electrons in its outer shell. Magnesium lost 2 electrons and became Mg2+. Why the positive charge? Because it lost electrons. And its electron configuration is 2, 8, with 8 electrons in the outer shell, and we express the charge as 2+. Oxygen becomes O2- because it gains 2 electrons, and its electron configuration is 2, 8 between brackets, and 2- is the charge of the ion on the top right corner. O2- has 8 electrons in its outer shell because the 2 electrons it gained from magnesium are added to the 6 electrons it already had. And therefore 2 + 6 = 8. And 2- is the charge. Mg lost 2 electrons, and these were transferred to oxygen, which gained those 2 electrons. So Mg became Mg2+, and oxygen became O2-. An ionic bond is formed because there is transfer of electrons from magnesium to oxygen.